Have you ever wondered how the universe works? Why are galaxies moving away from each other at an increasing speed? For years, scientists have claimed that this process is driven by the mysterious dark energy. But is that really the case? What if this invisible force doesn't exist at all? Think about this. How well do we really know the cosmos? Could the laws of physics operate differently in its distant corners than they do here on Earth? Can time flow faster in one place and slower in another? How is it possible that the spaces between galaxies can appear like bubbles of space-time, changing what we see and measure? And what about the age of the universe? How can we be sure we know it exactly when some regions may have existed longer than others? And does everything we observe truly indicate that the cosmos is expanding? Or could it just be an illusion due to our perspective? In this video, we will try to find answers to these questions. We'll explore what the latest research on supernovae tells us about our cosmological model. Could the time image theory replace the current standard model? And what does all of this mean for our understanding of the universe? Stay with me. Together, we'll discover how many mysteries the cosmos still holds. Dark energy is something we've invented to explain the mystery. Why are galaxies moving away from each other faster and faster instead of slowing down due to gravity? It sounds like a simple solution, an invisible force driving the expansion of the universe. But is this the real answer, or just a band-aid for something we don't understand? Let's think. Do we really need to assume the existence of invisible energy to explain how the cosmos works? What if the expansion of the universe is just an illusion? Imagine that time flows at different speeds in different parts of the cosmos, faster in empty spaces and slower in denser regions where galaxies dominate. Could this explain the differences we observe? Now think about this. If time flows differently in various places, what does that mean for our way of measuring distances? For example, could it be that light from distant galaxies, which we assume is speeding away at an incredible rate, is simply traveling through different space-time conditions? It's a bit like looking at objects through a glass of water. The image is distorted, but the object itself doesn't change. The time image theory suggests that what we perceive as the expansion of the universe could be an effect of how time behaves in different locations. And if that's the case, how can we be sure that the age of the universe is 13.8 billion years? Maybe different regions of the cosmos have different lifespans. What about other observations? Does the fact that the universe looks like a giant web of galaxies separated by voids suggest that we're dealing with something much more complicated than uniform expansion? If we live in bubbles of space-time, could our observations be limited to our local bubble? And here's the question that keeps scientists up at night. When we look at the universe, are we seeing reality or just its illusion? Maybe the galaxies that seem to be moving away aren't really doing so, and we're simply misinterpreting the data. Did you know that back in 2017, researchers noticed that the time image theory might explain observations better than the classical cosmological model? Since then, data from over 500 supernovae, star explosions that act like cosmic lighthouses, have been collected. With their help, scientists are trying to see if these time differences could indeed explain what we observe. Ask yourself, what if the universe isn't expanding the way we thought it was? What if instead space and time are playing a game with us that we don't fully understand yet? Are we ready for such a revolution in science? Or maybe this is just another step in discovering how incredibly strange our universe really is. If this intrigues you, stay with me. Let's try to answer these questions together. All these questions, whether dark energy exists or if time flows differently in various parts of the cosmos, sound like science fiction. But these are the very questions scientists are trying to answer by analyzing some of the most spectacular phenomena in the universe: supernova explosions. Why supernovae? Because they are perfect cosmic lighthouses. When a massive star ends its life in a huge explosion, it shines with a very predictable brightness. It's like having billions of identical light bulbs scattered across the universe. This allows us to precisely measure their distance, speed of recession, and direction of motion. If something doesn't match our theories, supernovae are the first to reveal it. And that's exactly what happened. In 2 independent studies, scientists looked at data from over 1,500 supernovae. The result? The observations don't seem to fit the classical cosmological model. But instead of pointing to dark energy, the data might suggest something completely different. Differences in the passage of time in different parts of the cosmos. Think about this for a moment. If this theory is true, it would mean that in the empty spaces between galaxies, more time may have passed than in areas filled with matter. What does that mean for our calculations? Could it be that the age of the universe, currently estimated at 13.8 billion years, is just an average value that doesn't account for these differences? It's like looking at a painting in a gallery through glass of varying thickness. In one spot, the colors are vivid, in another, distorted, and in yet another, completely blurred. Is what we see really the truth? Even more fascinating is what these studies suggest about the future. If we don't need dark energy to explain the expansion of the universe, could it be that the cosmos isn't expanding at all? Maybe it's all an illusion due to our local perspective, the effect of looking at the light from supernovae through distorted bubbles of space-time. The scientists who conducted these studies argue that the time image theory, which posits differences in the rate at which time passes, might fit the reality better than the current cosmological model. Imagine looking at the universe and thinking you're seeing its true nature, when in reality, you're like an observer in a funhouse mirror. Now, the most important question: how can we test this? The answer lies in even more precise measurements of supernovae, analyzing the light coming from distant galaxies and studying the empty spaces of the cosmos. Scientists predict that in the next few years, we may get an answer that will revolutionize our understanding of the universe. So, what do you think? Is it possible that our understanding of the cosmos is so limited that we're only seeing a fragment of the whole? If this theory holds true, it might turn out that we don't need dark energy to explain the expansion of the universe, and that would be one of the greatest discoveries in the history of science. Are we ready for that? So what can we take away from all of this? Does dark energy really not exist? Does the time image theory actually provide a better explanation than the standard cosmological model? Answers to these questions are still on the horizon, but one thing is certain. Our view of the universe is far more complex and fascinating than we ever imagined. Think about this. If time flows differently in various parts of the cosmos, are our measuring tools even capable of giving us a true picture of reality? Is our entire understanding of space, time, and matter built on assumptions that could turn out to be wrong? And one more thing. What if these bubbles of space-time are not just an interesting curiosity, but the key to understanding how the universe works at the most fundamental level? Perhaps the empty spaces between galaxies hold the answers to questions we haven't even asked yet. This is the beauty of science. Every question we ask opens the door to dozens of new ones. Even if dark energy turns out to be unnecessary and our standard model of the universe requires serious revision, it won't be a failure. It will be a step forward in our endless journey to understand where and who we are. What do you think about this? Are we on the brink of a revolution in cosmology? Or maybe the universe has even more surprises than we can imagine. Share your thoughts in the comments. If you liked this video, don't forget to leave a like and subscribe to the channel. It's a huge motivation for me to create more content about the cosmos and science. Also, check out other videos on the channel. You'll find more topics that will let you look at the universe from a completely new perspective. Thanks for being with me, and see you in the next episode.